Hello, everyone, and welcome to this evening's webinar on threats to fish in Nebraska with Mark Pegg, Fisheries Ecologist at the University of Nebraska-Lincoln. My name is Laura Coates, and I'm an AmeriCorps member serving with Conservation Nebraska's Common Ground program. Conservation Nebraska's mission is to protect our state's natural legacy by educating the public, supporting communities, and increasing civic engagement, which we accomplish through locally led education efforts and community engagement projects to address local conservation concerns. Before we get started, I have a few housekeeping rules to go over. Those of you watching online have your cameras off and are muted throughout the presentation. Please type any questions you have in the chat or the Q&A section, and we will answer those at some point during the presentation. We will have a very brief survey following the presentation that should only take less than a minute to complete. This survey helps support programming like this one, so we appreciate you taking the time to fill those out. This webinar will be recorded and uploaded to YouTube at a later date in case anyone missed anything or wants to watch it later. If anyone is interested in speaking with the Conservation Nebraska member regarding conservation issues in Nebraska, or to find out more about what we do, I will type our email in the chat and you can feel free to reach out to us. This evening, we welcome Mark Pegg, Fisheries Ecologist at the University of Nebraska-Lincoln. Thank you for everyone for joining us, and Mark, I will let you take it away.
Great. Thank you. Thanks everybody for showing up on a hot and muggy, I guess, Friday night. Have to start off this with a bit of a precursor that I'm in a little bit of a brain fog. We're about a day and a half into a new puppy, so hopefully this all comes off fairly coherent. So we'll see how it goes. Uh, yeah, I'm going to talk a little bit about, I think I'm going to possibly. There we go. I'm going to talk a little bit about some of the threats that I think we're facing in Nebraska and probably lots of other places as well. Just to kind of put all this into context from where my background is, this is kind of a very quick bio on me. I've been a fisheries biologist for about 35 years now, I guess, and working uh, through through both state and also now university agencies and organizations. So um, I'm a fish biologist by training, and that's kind of where you're going to see my perspective from for today. So let's get this rolling here. There we go. So what I'm going to do tonight is just give you a little bit of background, a very short background on the aquatic resources in Nebraska, just a slide or two, kind of hit some of the I'm not sure if it's highlights, but some of the key points on some of the threats that I think we face. And then if I haven't put you all to sleep by then, we'll talk a little bit about a case study of how at least the state of Nebraska has gone about mitigating some of these threats. So to kick things off here, I'm sure a lot of you probably already know there's a lot of water sources out there in Nebraska. We have somewhere in the neighborhood of 18,000 miles of actual permanent streams. I'm going to shut my image off just to keep my stability going here. And then we have about 2,600 or so lakes that are sort of public access. I know there's a lot more than that with farm ponds and stock tanks and lots of other things in the sandhills and elsewhere. But the ones that you see on the dots are really the ones that people can get to. So a fair amount of the public can get to. So a fair amount of resources to be had out there. Um, so so that's a very quick overview of the aquatic resources. I'll come back and talk about those in a little bit more detail in a bit, kind of towards the end here. But I wanted to start off with everybody knows what a threat is, I think, but just to put it into context here on what we're talking about, the threat is really a person or thing that can cause damage or danger. I'm kind of a dad joke kind of guy and a meme guy, so you're gonna see a few of these silly little pictures sprinkled throughout. So really what we're talking about for tonight is the threats are loosely interpreted as anything that can influence in some manner and generally considered a negative thing given the threat side of the equation. So in pulling this together, I kind of have 5 or 6 big areas of where I think we have some of the larger issues facing fish populations across the state. One is habitat change or loss, uh, pollution, and I'll talk about those kind of together. They're kind of intermingled. Aquatic invasive species, overharvest, and then um, climate change or changing climate in terms of temperature and water availability. That could actually come from a lot of other sources beyond just what's happening in the climate world of things. So this image here on the right is just an image that I stole from this Newell et al. Paper, and it kind of highlights some of the main barriers that they found as threats to the fish, and it kind of incorporates all those 5 kind of big bullet points. Fish barriers, flow regime, introduced fish, all that stuff. They're very much intertwined, so it's hard to really pick out any one single thing as the predominant threat. But as we kind of go through here, you'll see some of the I guess collision of topics here in some shape or form. So these are the kind of areas that we're going to talk about in some detail. Uh, so the other thing that I need to mention here is that a lot of times these threats are very contextual, depending on who the players are, the stakeholders, who's got an interest in conserving, preserving, whatever the situation might be, a species. It can be related to game fish, it can be related to non-game fish, threatened, federally threatened and endangered species, and on down the line. So the contextual thing here really does come into play, and where the human interests lie really dictates where I guess us as fisheries biologists have some tools to actually go about trying to mitigate some of these threats. And some are much easier than others, as probably would be expected. So just keep in mind that it's all a contextual thing. So as we dive into these topics here, we want to kind of loop habitat change and loss and pollution together. Again, a lot of those are not necessarily mutually exclusive, and especially in these two combinations. For example, erosion in the pollution section that I have here for both urban and agriculture certainly impacts the habitat availability of aquatic resources and probably terrestrial for that matter, in ways that kind of cross beyond just water quality. It can change the water availability as well. So keep that in mind as we continue to go through this. Just a bit of a grocery list of some of the common stream problems that we have in Nebraska and lots of other places. We as humans have put a bunch of dams in rivers, primarily a few streams, and that causes some issues with flow management. So we have flashy flows related to hydropeaking when we turn our ACs on. For example, the Platte River drops a little bit for a little while, and then it will come back when they turn the generators back a bit. So it's just a situation that we're dealing with. It can also happen with flooding, drought, lots of other reasons for flows to be flashy beyond reasons that are just dams and hydropeaking. A lot of times, for example, in urban settings, a lot of the concrete and paved parking lots don't actually allow ground saturation, so they um, push a lot of water into a stream fairly quickly and without a lot of warning, so that can be a flashy thing as well. Temperature extremes, especially in shallower water, that can be an issue. Unstable banks, that's probably one of the bigger issues that we face across Nebraska with eroding banks. Some of our soil types are pretty conducive to erosion. That ties into a lot of other sedimentation issues that we'll talk about in a little bit more detail when we talk about reservoirs specifically. Um, Sedimentation, I guess I had down there number 5. Uh, a lot of that then ties into the life history aspects of the fish. So there's things like not enough habitat to provide spawning or feeding or any other kind of connected behavior that allows the fish to um, complete their life cycle. And one of the things that I guess I've dealt with off and on through is block migration routes. We don't think of migration in the Great Plains and the Midwest for fish all that much. But I've been doing quite a bit of telemetry over the last 10 or 15 years, and there are certainly fish that do rely on migration routes that have been blocked or changed in some way. So that connectivity to habitats is also a big thing. So to talk a little bit we talk a lot of times about water quality, but there's also for fish and some other sort of terrestrial and aquatic terrestrial organisms, when that flow hits in terms of quantity and the timing of that can also be a big a big issue. One of the things, for example, that we deal with in the Pacific Northwest is uh, trout streams need a pulse of water to get the trout to focus on their home, or salmon to focus on their home stream to go spawn. We have sort of an analogous thing with that with some of the sturgeon species in the Missouri River. We believe they need a pulse of flow to kind of kick their migratory and movement behavior into a setting where they're going to go to spawning areas. So a lot of times the question related to fish threats and water quality, I guess, is just focused on quality, but it can be also quantity and the timing of when that quantity happens. So it's, as is with everything, I guess it's not a very simple and straightforward question or answer to deal with when we're talking about threats to habitat from a fisheries perspective. Just as an example of that timing, kind of how it's changed through time. This is a graph of several gauge stations in the Missouri River system. So Fort Benton, Wolf Point, all of these points here are gauges. And then on the left here, we have a period of in that green circle is annual flows during a period when we didn't have a lot of dams in the system. The first main stem dam on the Missouri River was closed in 1937, I believe, Fort Benton. So we see an annual flood pulse kind of pop off every year or so with that. When we look at the post impoundments, so in the 1960s and on, especially looking through Bismarck and Omaha here, the next green circle, uh, what's happened is that we've actually raised the flows and raised the annual flow a little bit, and then dampened the flood pulses. So the timing of that has been kind of knocked down, and so that can lead to some issues as it relates to timing of spawning habitat or going to spawning habitats and that sort of thing. So um, it's created some benefits in other ways, and we can talk about those for sure. I mean, the reservoirs have created great fisheries, so depending on your perspective, they can be a great thing or a troublesome thing. Uh, so yeah, so that's the timing issue, if you will. Oops, let me see if I can get that. Well, thought I was getting cute with the annotation, and now I can't get it off. Well, just pile through things here. Sorry about that. Um, anyway, I'll keep working on these uh green circles here in a second. But the things that we deal with from lake standpoints are uh ah, are generally related to nutrients and kind of habitat modification related to aquatic vegetation. So, in the especially in agricultural areas and urban areas where herbicides are used a lot, and or not necessarily herbicides, but fertilizer um, for both agriculture and a lot of golf courses are probably one of the bigger contributors to nitrogen and phosphorus in the urban setting, in addition to lots of other lawn maintenance and whatnot. But it's not any one source is the biggest smoking gun. I don't believe it depends on the situation. So lots of nutrients come in that may on the face seem like a good thing, but eventually that causes some issues with things that we don't want. The microcystin or the blue-green algae blooms that many of you probably know about are prevalent across Nebraska at certain times of the year when it gets hot. Those blue-green algae can be fairly lethal to pets and certainly cause some issues for people as well. So there's advisories to slow that down. And a lot of that is from a long history of additional inputs of primarily nitrogen and phosphorus, but it could also be some ambient stuff as well. That leads then to poor dissolved oxygen at times. Um, and just a blue-green sea of muck that nobody wants to really look at too closely, I don't think. So, and then a lot of times in Nebraska, we have a lot of wave action. So, or excuse me, a lot of wind action that causes wave action, and that can actually destroy or deteriorate the shoreline. A lot of the reservoirs now have some means to control or direct the wind so that the wind fetch isn't actually causing a lot of damage to the line. So. All right. So that was a very quick overview of pollution and uh, uh, habitat changes. We can One of the next big things I think that we as fisheries biologists at least have a little bit of control over is some of the aquatic invasive species. Um, the uh, the 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 I guess poster children that we're dealing with now from an aquatic invasive species are primarily the fish on the right, the big-headed carps. So that includes big-head carp, grass carp, silver carp, and black carp. The two biggie, well, the one big that everybody knows because they jump is a silver carp. If you're driving around in a boat, or they can certainly jump out of the water and clobber you. I've been hit more times than I care to admit. But they can cause a lot of damage to the populations of fish that they're competing with. And I'll get into some of that in just a minute. On the right here is a boat prop with a colony of zebra mussels on it. We do have zebra mussels now in a couple of spots. The Missouri River has them for sure, and a couple of lakes in Omaha have uh, been tested positive, and kind of a bit of management has gone on to try to eradicate them or control it. The curly pondweed on the lower right is certainly around in eastern Nebraska anyway. And then the one on the left bottom, we haven't actually seen any of those in Nebraska yet, but we think they're coming. It's a northern snakehead. They're pretty aggressive predators, so we think they might be fairly competitive and damaging to the entire fish community, but especially some of the sport fish in the reservoirs where they can pretty much clean out a lot of the other desirable species. Um, so there's a lot of aquatic invasive species out there. I think the last count I saw for the Mississippi River Basin, which we're part of, there was something like 150 or 160 aquatic invasive species in total that were in the entire basin. So there's a lot of fodder out there to worry about, and some probably aren't going to cause a lot of damage or threats, if you will, but others may pose larger threats. So those are the ones we're facing now. Maybe a little more, I don't know, closer to home or interesting, I guess maybe is a better thing. Largemouth bass are native to the eastern part of the U.S., but if you look at the east coast of Nebraska, they were in the Missouri River Basin, but folks don't believe they were actually all that native to most of what we call or where we find largemouth bass in Nebraska. Um, it's a little bit of a debate, I suppose, on where they're native or not native. But what is not a debate is largemouth bass have been introduced across the globe and have caused some similar damage to the things that we're dealing with here elsewhere. Interestingly, I think the world record largemouth bass now is from either South Africa or Japan, of all places. So other places can grow them pretty well too. And then the common carp is sort of a not a sport fish per se, but has been one of the most broadly distributed species, primarily by humans. In the world, it's pretty much everywhere. I think all but Antarctica, I think, is the last I saw. Won't expect them to be in Antarctica, I guess, but and those carp do a lot of damage to the habitat. They typically feed and root around in the sediment and uproot plants, and they cause increased water turbidity, so less water clarity, damage the habitat from a vegetation standpoint, and just really wreak some havoc. They've been here for a long time. The mid to late 1800s is when they really started to show up but in North America. So they're here. We don't really know to the full extent of the damage that they have done, but we do know what they are doing in places we trying to eradicate them. The sandhills in the Valentine Refuge area, the Game and Parks folks and the Fish and Wildlife Service have spent quite a bit of time and effort to get the carp out of a few of those lakes up in the refuge area to try to keep the habitat viable for the native fishes that are up there. So lots of work could and can be done for the common carp as well. All right, so um, probably get before I get too deep into invasive species, we need to talk a little bit about what causes the problems. Why do we care so much about aquatic invasive species? Well, the truth is some of those we don't necessarily worry too much about, but others that have some competitive advantage on things are 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 uh, the ones we worry about most if they can actually outcompete our native species. Like I mentioned, the carp, the big-headed carps, big heads and silvers, they are filter feeders, so they eat primarily microscopic zooplankton and phytoplankton, algae and small crustaceans. And that's pretty much what every fish at some point in their life eats. So they can really knock out the floor from the food chain. So that's why we're so worried about those species right now. So they have a competitive advantage potentially. Um, they also, a lot of times, aggressive maybe isn't quite the right word, but they are prolific in terms of spawning. I'll show you a picture of a big head carp that we caught a few years ago. Um, so they reproduce or they feed very voraciously. We have white perch in the eastern part of Nebraska. They're very aggressive during the spawning season. They'll eat a lot of the eggs and larvae of bass, bluegill, um, lots of minnows and other stuff. So that has caused a fair amount of worry over the years as well. Uh, and then the disease and parasites angle is maybe it's not a stretch, but it's a little less common, I suppose, in terms of we do have a carp virus now that has come through and thankfully primarily only deals impacts the carp, but there is some collateral damage, if you will. Some of the other parasites that come with those fish when they're introduced also have can cause some problems. But probably the big ones that we see and are very tangible, if you will, are the predation and the competitors for habitat or other food resources or what have you. So there was a study done, about 20 years ago, I guess now, in the Mississippi River system where bighead and silver carp came in, and they did the I believe it was the Corps of Engineers sampled a couple of bays where the or backwaters, and they found that 95% of the biomass was only the invasive species and all the native species have been pushed out, so there can be competition for a lot of other things beyond just food too. To drive that point home, man, I wish I could remember how to get rid of that silly. Oops, that's not it. So anyway, I will quit pushing buttons. To kind of drive the point home on the reproductive and the competition side of things, this was actually I worked in Illinois in the Illinois River back in the early 2000s, and you can see that kind of picture in the background is just a little inlet, and all those fish that you see popped up are big head carp. Most of them were females in the same range as the one that I'm holding there. That was about a 45-ish pound female, and she had about a little over 2 million eggs in her. And there were literally hundreds of those fish right there. So, even if only a tenth of a percent of those offspring survived, it doesn't take too long to really illustrate how big the population could be fairly quickly. So, um, that's a reproductive capacity compounded by the competition for food resources that has us all pretty worried. Although maybe think they've been here for a while now, and in some places they've sort of stabilized, I guess, for want of a better term. I'm not sure that's a good stabilization, but they haven't continued to increase in their population size to any huge extent. All right, so probably the smallest impact or threat to fishes, or uh, I shouldn't say the smallest, but the one that we have the best ability to kind of control as fisheries biologist is overharvest. Overharvest, generally speaking, doesn't happen in the same capacity in recreational fisheries as it does in like commercial fishing. That is, we don't typically crash populations the same way. If you've read um, the books about the cod collapse in the East Coast, that's a much different thing than what we have to deal with on the recreational side. Typically, what we deal with is a lot of uh, implications with too much angling pressure in some places or too much harvest. And so, what you're seeing, too much harvest to an extent, but it doesn't actually change the population size, if you will. It changes the size structure. So what you see on this left graph, or excuse me, this right graph is an example of of what we call stockpiling. So if that red dashed line is theoretically the minimum length limit, a lot of times lakes, especially this happens with like crappie and sometimes bass, a lot of times the harvest will occur pretty much right at that red dashed line all the way up to however big they get, so that the population that's susceptible to angling gets clipped off pretty effectively. But there's lots of little fish to backfill. But what happens then is they kind of get stalled right at that right below the size limit. So a lot of times you'll hear people talk about stunted bluegill populations. It's sort of the same thing, a little different context, but generally what's happening is there's so many of them that they don't grow very fast. Um, because they're competing for food themselves, and they kind of top out or get clipped off if they hit that minimum length limit. So what happens when we have this stockpiling angle is something that you see on this picture of the bluegill on the lower left here. This is a bluegill. Relative weight is a metric we use to assess kind of the general condition of a fish. It's usually an index against what a kind of a standard fish of a given length should be. So that index should be 100. And this one was 36.5. That's actually lower than I've ever seen. Usually, if you see 60 or 70, the fish are pretty much emaciated and not doing all that well. And this one was 30, 36 and a half, 37. So that population is probably not doing all that well. So overfishing can be an issue in a sense, but we actually have some pretty good tools to, we can release the size limit for a year or two or 10, 5, 10, how many ever we need to, till we kind of even the population back out, and then we can kind of reassess from there. So that one is pretty controllable, although it's not a fast control. It does happen fairly frequently within the fisheries management side of the equation. All right, so uh, getting into the potentially the 800-pound gorilla in the room, I'm not going to necessarily get too deep into climate change, other than there are, the climate is dynamic, so we're changing. There is some prediction that air temperatures will increase fairly dramatically by the middle of this century and next century. What is less clear, I think, for from a fisheries perspective, is how water temperatures are going to change. There's other places where in the world where water water temperature in streams and rivers typically are very highly and tightly correlated to air temperature. We can pretty much draw not a one-to-one relationship, but there is a predictable relationship there. Because a lot of Nebraska is groundwater fed, the water temperatures uh, become a little bit disconnected, if you will, to the air temperature. So we can't necessarily use the climate change models to predict what water temperatures in the rivers and streams specifically are going to be. But what I guess the message here is that the patterns of temperatures, the patterns of precipitation have been changing and are changing and probably will continue to change till the sun burns out. So we're having to deal with that in some capacity. And so one of the things that we were interested in is if water temperatures do rise in rivers and streams, if you look at a map of Nebraska, like trees, I think there have been couple of studies that have shown that like trees, their distribution is shuffling north for some of the more warmer climates. I'm going to put a human term to it, but they're moving north. I don't think that's really they're not moving, but their distribution is shuffling north a little bit. So if we use that same kind of mindset for fish in Nebraska, you can see in this that all the rivers run from pretty much west to east. So if that population of fish that's under threat of higher temperatures, flashier water, whatever the situation might be related to any changes in the climate, they would effectively have to move out to the Missouri River, potentially several hundred miles, and then up the Missouri River to colder climates. So it's a lot bigger of a hurdle, if you will, if they were going to kind of make that conscious decision. So what we wanted to do is kind of look at what barriers are out there to that sort of population movement. Again, it's not going to happen fast. It's just going to be as some populations die out, they'll move downstream and find a better habitats, hopefully. But we want to, some of the things that become an issue are dams and road crossing culverts and that sort of thing. So we wanted to look in Nebraska and see what sort of roadblocks, sorry for the pun
Uh,
there, there
Mark,
were. Yeah.
someone put in the chat a way you might be able to erase the green highlight. There
Uh,
should be the annotation toolbar, the eraser tool.
yeah. Yeah, it's just not coming up for me for some reason.
Let's see.
So,
Mm, Okay, I think I figured out how to
oh,
get it.
you got it. That's good. Maybe I didn't have control. The eraser wouldn't actually show up for me. So thank you. So much for technology. That's what old guys get for trying to do fancy stuff, I guess. Um, so anyway, we're looking at trying to figure out if fish can move downstream through a lot of these places and then further upstream. So the there's a lot of potential pinch points, if you will. I don't have a very good picture of it here, but there are several culverts across the state that are more than a 2 or 3 foot drop. So fish may or may not be able to, certainly wouldn't be able to move upstream from that. May or may not be able to go downstream through it, depending on what's going on with the culvert. So essentially we just wanted to do kind of a academic exercise to see how many road crossings and dams are out there across the landscape in Nebraska. And we actually did this for the entire Missouri River Basin, but I'll just talk about Nebraska for now. So we asked a couple of questions. How many potential barriers are out there? I pretty well beat that one to death. And can if if all things were perfect, can we actually model a potential distributional shift if they wanted to seek their cooler or more ideal temperatures? And then probably more interestingly is which species might be impacted by those barriers. So here we have a map, and each dot is a three meter high or higher dam. This is from the National Highway uh, Commission. So board coverage, sorry, USG or GIS coverage. So there's about I think 1,500 or so of these, and that's not all of the dams by any means. There's a lot of, like I mentioned earlier, farm ponds and whatnot that don't meet the criteria, but these are the ones that are recorded in the federal dam data registry. Um, and so what I was gonna try to do, and I might be a little gun shy about that now, but I was gonna have folks guess how many road crossings there were in Nebraska to kind of correlate to the impoundments as well. So we have 1,500 impoundments. If somebody is crazy enough to try to throw something in the chat, we can throw a guess or two out and see what happens. 2,000. That's a good start. But it's actually quite a bit higher than that. So every one of these dots is a place where a road crosses a stream. And in Nebraska, there's about 110,000 of those. Now, that is not any implication that they're all barriers by any means. I mean, some of them are, most of them, I'm sure, are fine, but there are a few out there that may cause problems. So we don't really know that bit of the equation yet, so we couldn't really look at where there might be pinch points or not. Some other folks have continued on with some of that work, I think, in the past or in the since we did this study, but uh, it kind of blew my mind that there were that many potential road crossings in Nebraska. And if you look at some of the other states, like Montana has 140,000, it's just kind of crazy to think about how many potential issues we might have. And again, not saying that all of those are, um, but there's a lot of it's a target-rich environment to figure out which ones are, I guess. So to cut to the chase, then we did some modeling and using thermal temperature ranges from fish, and this is not overly fancy graph or easily interpreted graph, but each one of these dots, like the lower right hand one, the blue, I guess, I don't know, blue green one, shows the one that's in Missouri shows a movement for the first 50 years and then to a little bit to the north and then another one in the next 100 years. But the model showed that there is some movement north if they can get there. It's not a lot for most of them. Some for few that it was a bit more. But I think again, what the important thing that we really came through here was we using the life histories of the fish that we deal with in Nebraska, we whittled down the list to those that are sensitive to temperature. If temperature changes, those are the fish on the left, and those that are more sensitive to changes in flow on the right. And when we kind of collate all of that into where the biggest threats might be should temperature and flow change, we get to a list of most vulnerable species, and most of those are not fish that probably most of you run into. Long-nosed sucker, white sucker, log perch are not sport fish. Yellow perch is, but mostly those are contained in some of the lakes more so than rivers. So um, not exactly sure what that might entail in the final story, but um, what it does help us kind of dial in on is where some of these species might fall in our keep an eye on list, if you will. And so Nebraska Game and Parks has a lot of um, information on a lot of these species in addition to others in their heritage database. And so they're keeping an eye on a lot of these species, especially the ones sensitive to temperature. There's a lot of the western silvery minnow, brassy minnow, pearl dace. Those ones are pretty. Um, they're glacial relics of sorts, so they're kind of only in the certain parts of Nebraska right now, and are probably fairly vulnerable to a lot of other things than just temperature and flow change as well. So that's what we can do with the climate change. So this is again a big milieu of stuff that we try to kind of cross pollinate and cross understand, but realistically, as a fisheries biologist, we don't really have a whole lot of control over um, a lot of the things that happen to the aquatic systems. There's lots of other societal demands on things, so that's not good, bad, or otherwise. It's just the way things live. So what we tend to do is this. There's a new-ish concept, I guess, although it's pretty common sense, called the RAD approach to fisheries management, where we either resist the change, we accept the change and allow the ecosystem to do whatever, or we try to direct it in some capacity. And those can all happen in different degrees of effectiveness and effort, but that's kind of the conceptualization that we're using right now to to kind of direct and guide some of the measures and discussions of pros and cons. And so what I want to do just quickly here, I guess I better talk a little faster. I'm getting long-winded. Is just run you through a quick case study on reservoir aging. We have a lot of reservoirs in Nebraska, and this image you're seeing here is from one of the first publications in the 1930s that really started to study reservoir water dynamics. And so we have on the right-hand side the river coming in, flowing in towards the left. And so the rivers comes in with a lot of sediment and nutrients. And as it starts to slow down in that transition zone in the middle, it starts to drop some of those sediments out, and eventually that starts to fill the lake in, and we get to a point where it's called reservoir aging. And all lakes age as well, but the reservoirs, because we've put a dam in a place that wasn't necessarily a natural pinch point for water, it essentially increased the sedimentation rate. So that's a known thing. When they built the reservoirs, people knew they engineered for it. But we're getting to an interesting kind of point in time where some of that infrastructure is really starting to begin to time out. So before I get into the timeout side of things, I just want to walk you through the phase of the aging process. So if we use this blue line as some measure of productivity, it could be the amount of bass or water ski habitat, whatever you want it to be, as a measure of productivity. Starting from the left of that line and moving to the right, there is a progression in how the reservoir behaves. And so in the first bit, it's a bit of an ambiguous time, but say the first 10 years, we have this trophic upsurge. The area is flooded, so a lot of the nutrients and organic matter that was in the soil or whatever else was in the area that was flooded release those nutrients into the water, and those become very productive systems, very fast growth of fish, lots of other good things happening there. So that's kind of the up and coming stage for reservoirs, and I kind of liken it to this guy with the tattoo of a Red Bull and a Jägermeister. It's just a big shot of energy and nutrients to the system. Then we get to that kind of the asymptote, the peak of that line for a bit of time, where we get to the desired state. So maybe that's a target number of fish or types of fish or what have you. And then eventually, as the reservoir starts to fill in and some other aging processes kick in, we get to a point where the fish are not uh, growing or surviving the way we want to. The habitat availability isn't the same, and on down the line. So that becomes a much more declining system. Um, and that's a long, drawn out period. But what we're essentially trying to do is try not to let things get too far down that right side of the line. And so um, one interesting thing as we've dug through this is we have somewhere in the neighborhood of 80 odd thousand dams that are that 3 meters high or higher. And most of them were engineered for a 50-year kind of operational life. That doesn't mean they're going to fill up in 50 years, but that's kind of the operation and maintenance of things from a financial planning side. So we're well past that for a lot of the reservoirs. And what it really comes to is what's going to happen when these things start to fill in or deal with that aging process that creates a bad fishery or too small of a reservoir to buffer flooding and those kinds of things. So um, just as an example here, this is a lake in California back in 1947. It had about 7,000 acre feet of water holding capacity. And then by 2020, it actually was down to 150 acre feet. So much filled in and unfunctional at that point. And there's a few other examples of some of those as well. A little closer to home. This is an aerial photo of Lewis and Clark Lake up on the Missouri River upstream from Yankton, South Dakota. And so the top graph shows where the delta, so that's kind of that transition zone from the conceptual diagram I showed a bit earlier that has the braided channel and sandbars and whatnot on the left. Uh, with all the deposition of sediment that's coming into that reservoir, that delta or transition zone has actually moved about a mile or so downstream in about 30 years, which doesn't seem like a lot, but it's a lot of material. I'm drawing a blank on the amount of cubic feet of soil and sediment that's deposited, but eventually Lewis and Clark Lake will fill in. It won't be in our lifetimes probably, but it's an issue of concern. So the question then is, how do we or should we slow that process? And so essentially what we're trying to do, if we look at the left line, the typical aging trajectory, we're just trying to shoot a little bit of adrenaline into the system with some sort of an action plan to try to get it back up above a minimum desired state. So that could be number of fish, amount of acres to store water, etc. And so Nebraska, actually, the Game and Parks Commission has been what I would say at the forefront of aquatic habitat plans for the across the country. They were the first one to have an actual aquatic habitat stamp that fed directly into doing a bunch of this reservoir rehabilitation to try to slow down the aging process. And so what the idea here is we've been coining it, trying to find the fountain of youth for reservoirs. So a lot of the things that fisheries biologists have at their disposal can have differing effects on the length of the duration of the restoration or the rehabilitation, the amplitude, how strong of a response, and then how long till we get back to below that. And I'm not going to bore you with a lot of gory details on that front to any great extent, except to show you there's a whole toolbox of tools, including aeration, um, doing windbreaks, wetlands, sediment basins, etc. And they all have different associated costs and impacts in terms of how long it lasts, how long it'll take for it to get back to some state that we don't like, etc., etc. So all of these things that are on this table have been used in various capacities by Game and Parks over the last 20 years for their aquatic habitat plan. So um, of course, we can have a plan until we know what works or doesn't work. Um, it's just a plan, and so we've been looking at some of the monitoring data that Game and Parks has from their annual sampling. This is just an example from Smith Lake. It's out in western Nebraska. Um, so the largemouth bass population in that lake pre-dredge was pretty low abundance, but also a little bit small on the size structure. And so about 5 years after they dredged a bunch of sediment out of that lake, The numbers went up, the size structure increased some, but there's some, so 500 millimeters would be about a 20-inch bass. So they got a little bit of a response out of that from bigger fish, but the big thing here is that there was a positive response from the populate from the bass population, and that dredging actually provided some benefit in other ways. They used the sediment to create some jetties and other fishing structures. So it's kind of a win-win for all the activities. So to kind of wrap things up here, I'm not entirely sure I covered anything in super deep depth here, but I'm happy to field questions as needed. What we are limited with, or I get not limited with, what we face are, the expectations from, say, the angling community versus conservation groups that are interested in endangered species recovery to people that want to do land development or whatever. So we're trying to navigate a lot of societal expectations, which doesn't give us a lot of tools in most situations, but there are some things we can do to at least mitigate the effects of, say, habitat loss or potentially even the invasive species issues. Of course, that all comes with costs and benefits of either doing or not doing anything. So, in a sense, no action is an action. Um, and so, one of the things that I don't think we're there yet, but what we may have to do in terms of understanding how fish populations could or may change given the myriad of threats that are out there to them is that it might not be the ideal fishery that we think it should be, but it might turn into something more that it can be. So this little pictorial graph shows largemouth bass and rainbow trout on the left. Uh, so that's a lot of the Missouri River reservoirs in South Dakota and North Dakota have what's called a two-tier fishery, a warm water fish, so the bass, and then they also have it's not trout, but they have salmon in the colder water. That may not be sustainable in the long run, depending on what happens. Um, but and then it might switch to a bluegill fishery, and then ultimately it may turn to something much less desirable, like a carp fishery, or something else. So those are the things that we face and are thinking about, and we circle back around to, um, you know, probably optimizing the things that we can successfully resist is good. It looks like my time's up. So, and things we can't, uh, we will have to learn to accept. So, with that, thank you all. Sorry, I probably bored you all to death, but I'm happy to take any questions if there are any. And this is this picture is a silver carp right at the mouth of the Platte River as it's jumping in to hit one of the Game and Parks biologists at the time. And so the threats are real, I guess, is the parting shot.
Yeah, we do have a question from Kay. In regard to the delta on the Missouri River, what would happen if Gavin's Point Dam was removed? Would that sediment move downstream?
That's a good question. So there has been, well, I guess the short answer is yes, it would be moved downstream. There's been couple of different discussions about how to deal with that. One was to pump the sediment to places that could use it, like a long ways away, like Oklahoma and Texas, which seems a little far sight or a little bit beyond reality expense wise. But the other thing was to just open the gates in at Gavin's Point, which is probably a more feasible thing to do, but it would flush all that sediment and decaying organic matter out and probably do some short-term damage to downstream of the dam. It would make everything anoxic. Not sure how far down it would go, but it would potentially help some of the sediment issues, though, that are being dealt with in the channelized part of the Missouri River. So it the short answer is yes, it would go downstream, or at least a lot of it would, but it may or may not cause a lot of other problems. And I'm not too intimate to the sediment dynamics of what would happen, but I know that other places where they've removed dams, there was a period of recovery below the dam once they removed it.
If anyone has more questions, feel free to type them into the chat. I launched the survey. We'll appreciate anyone who fills out the survey. And K Hall asks, how long did that recovery take?
Uh, the recovery on Smith Lake, that one was it was about 5 years. So a lot of times it takes a bit for the fish populations to respawn. Oh, oh, sorry, yes, that makes more sense. That's a good question. There's again, it's a contextual thing. Um, in the reservoirs that I know that they actually just blew the dam and let it all kind of flush out. They were in the Pacific Northwest and they were pretty close to the ocean, so they timed it when there wasn't a lot of fish in there. They were all migratory fish, so that recovery was pretty quick. I would assume that the short-term recovery would be fairly quick in terms of microbes and other things. The fish populations will take a little bit longer just because they have a longer life cycle, and they'll have to move in from, downstream or up in the tributaries for wherever they came from. So it's not a very good answer in terms of a definitive time, but I think it really depends on where you're at. The Pacific Northwest was pretty quick. And would it hurt the pallid sturgeon? Uh, Potentially, yeah. Whether there would be a long-term effect that would be a measurable thing, a little hard to say at this point, but certainly that anoxic zone would probably, as all that sludge and whatnot came down, it would probably take a few of them out, along with a lot of other fish too. But I guess the other thing, it wouldn't be all the way to St. Louis. I don't know how far it would be, but it would be a ways probably. George, you're not gonna grill me?
Thank you everyone for attending and have a good evening. If no one has any more questions, then feel free to head out.
Great. I guess we're done.
Yep, thank you.
All right. Thank you.